All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are back from a break. We took a week off last week just to kind of handle some things going on, IRL. And, quite honestly, I just kind of needed a break from it. So it's good to be back, though. And we're going to pick up where we left off before. So all good things there. So just as a little preview of, kind of where we're at, I did get some stuff accomplished offline. So you can see here, we actually are up and running. But before we jump into any details about that, I do want to take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Lazaron. It's the highest tier of subscription on Patreon, followed by our partners, Gaboli's Inc. and Matt Oscard. They are the next tier of subscription over there on Patreon and YouTube memberships, followed by our supporters listed here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So the support here goes towards covering the costs of running the channel, things like hosting fees, software licenses, eventually assets, things like that. And so I greatly appreciate the support. Thank you very much. It's very, very much appreciated. And I would be remiss if I didn't also give a big thank you to all of you, the viewers, whether you're joining us here live on the YouTube side or the Twitch side. We do simulcast both. Or if you're catching the VOD after the fact, that is totally cool too. Without you guys, this project would not exist. And so thank you guys very much for being here and following along. Okay, so Dr. Elliott, good to see you over there on the Twitch side. Hope you're doing well. So we've accomplished some stuff offline. And so we are now actually at the point where things are up and running again, kind of, sort of. If I were to go ahead and load this right now, it's going to poop itself. I could show you that real quickly. But that is partially because of one more thing we need to do. But right before it does that, we can see that, it is loading in assets as we would expect. We can see here by, just the fact that the water is loading up and all that stuff. We are actually back up and running again, just kind of in a bug troubleshooting mode. With that, there are a couple things that were accomplished offline to get us to that point. So we're going to kind of talk about that. The other thing that I've done is I actually kind of spaced things out a little bit in the Kohi roadmap. So this is the big to-do file that we manage. And so I'm just going to kind of move things around, kind of as we tackle different stuff, right? So we're currently working towards the 0.10 release. And so the refactor of the texture system was one of the things that we did. And so textures are now just a K texture. It's just a type def U32 essentially, or maybe it's a U16. I don't remember. Essentially, it's an ID. And so we don't have, large pointers with a whole bunch of information that we almost never use being passed around. Now it's just a number, right? And also no more pointers, right? So if we need that, we can use that to, retrieve any data that we do need. But that is going to be kind of the way forward, I think, for a few different systems. So that is done. And that is actually pushed up to the 0.10 release branch. In addition, we actually have, we have this refactor asset system to use direct types and dispense with handlers and import logic from engine. That is actually done. So all of that stuff has been moved out of the engine, and we have simplified that API, right? And so this sort of parent item here is done. Let's see. Oh, Dr. Elliott, thank you for the Prime sub. I appreciate that. Thank you, sir. Let me catch up on chat here, and then I'll get back to the code updates. Keep typing colon W in JetBrains now after using Helix for so long. Why are you using JetBrains? Be my question there. Did you get tired of Helix? Although what's funny is when I'm doing stuff for like work or something like that, and I'm not able to use Vim, I do the same thing all the time. I'm constantly hitting like, Shift V to do a line select and stuff like that. So you still use Writer for C++, but you use Helix for Rust. Fair enough. But you should see about, swapping over. Swap over to C++ on Helix. Or maybe Vim. NeoVim. Apotham, good to see you. How's it going? Welcome. All right. So the other big, and I say big thing in quotations, right, is I actually Jobified the VFS loading. So we talked about that a bunch of times. We said we're going to design the VFS in such a manner where it's going to be treated as asynchronous unless we specifically indicate that we want a synchronous load, right? And the way that we said we were going to do that was we were just going to Jobify the code, and we put in some comments about saying we need to Jobify this, and I said it was going to be really easy, right? And it was in fact super easy because of the way that we designed it. So we're going to take a look at how easy that was to make it work with our job system, and it fit in really nicely and just worked right away, which is pretty sweet. So before we jump into that, though, I just want to kind of talk about some of the other things that we want to do in 0.10. So we do want to finish the rework of the import pipeline. I'm probably going to wait and do that until last, but that's a little bit of a sub-item of this one, right? And then what we're going to be focusing on tonight is removing the resource system. And we're going to use the reworked asset system in dedicated systems. So we've already started this in a couple of our systems. Our material system already does this. Our texture system already does this. And so we're basically just going to go through and look at all of the other systems that are making use of that resource system. And we're going to go ahead and pull all that stuff out and get rid of that system. And that will greatly simplify the way that we
thank you for the content.
Load things. Thank you so much for the tier 1, Chrisus 16. Thank you very much. Appreciate that on a 2-month streak. Thank you so much. And I'm glad you're enjoying it. You're hearing Jobified the code, not Jobified? Yeah, I might be. Maybe I should drink some Gatorade, right? Maybe I'm not pronouncing it right. You guys kicked off a hype train, by the way. That's pretty cool. Helix is better than Vim. Use what you prefer, I guess, right? I will the day I can get my engine to work on Linux. Yeah, fair enough. Yeah, so I'm saying Jobified, right? So we use our job system to handle asynchronous VFS loading, right? Virtual file system loading. So we'll go over that in just a second. So we're going to remove the resource system and use that reworked asset system that we finished now directly. And we're going to remove that resource system as well as all the handlers and all that other crap, right? So we're actually going to wind up deleting a lot more code tonight. We're going to move some code, but I think we're going to be doing more deleting than removing. And then we're going to rework the way that hot reloading works. So systems will basically just say, hey, I want to register for this KAsset hot reloaded event here, and they'll handle it internally however they need to, right? And so that's the goal there. And that's going to complete 0.10. So I'm hoping to knock at least a good chunk of this one out tonight. If not all of it, we'll see how far we get. But before we do that, I do want to talk about this guy. So if we go into VFS, and I actually should bring up another thing. You'll notice that VFS is now no longer in core. It's under runtime, which makes sense anyways, because all of our core stuff didn't really have state set up to be able to use the VFS properly, and the VFS is only really ever used with the engine. So it makes sense that it be part of the runtime, not part of the core, because our tools don't use it, only our runtime uses it. And so that's been moved. And if we actually take a look at, let's see, I'm trying to remember exactly where that was. Here we go. So we have this VFS request asset, right? So we have this version of it, and then we have the synchronous version of it. And so essentially what used to exist here was there was a to-do that said jobify this, and then there was another to-do that says this is going to be the result of the job running. And we were essentially able to move that code directly and use it as is without a whole lot of effort. So all we had to do to jobify this was we had to split things into a couple different functions, right? So we have a job start, which is sort of the entry point of the job, and then a function callback for success and one for failure. Which the failure one we only sort of bleat about the issue for now. We may handle something. We may handle that differently some other time, but at least for now, that's kind of the way it works, right? So a VFS asset request essentially puts together some job params. So this is a very simple structure that has a pointer to the state for the VFS system, and then a copy of the initial request info, right? So we fill out one of those guys and then call job create, passing our function pointers, our params, the size of that, and then we create or we allocate internally a VFS asset job result. And that job result is essentially what gets called whenever we have a success, or technically a failure, could call this too, and just not have things filled out. But again, we have a pointer to the state. Now we actually have VFS asset data, right? So that's where that asset data comes in. And then we have the original request info if we need it. And so the way that this works is we essentially have the entry point here, which all this really does is just call the synchronous method, and then returns our data, right? But this is done on a job thread, so no matter how long this takes to run, it doesn't really matter, right? And then all we do is we return a Boolean whether or not the result equals success. And so that is all that this really does. We just had to kind of move this code around, right? So this goes ahead and loads that, and then sets in the out result data. It sets the, of course, the asset data, the state, and the info. And then on success, we go ahead and we check to see if the info had a callback. If we do, we issue it. And then we have some additional logic here about if we are supposed to watch for hot reload, or if we're not supposed to watch for hot reload, rather. Then we go ahead and clear up the context in the import params. And again, we're going to have couple additional things to do about hot reloading, but not really a big deal, right? But suffice it to say, all I really had to do was move some code around and create a couple structures for the actual job creation, right? So we create the job here. That just fills out this job info struct, and then we submit it to the job system here, and it kicks off on the next update, and it's automatically handled for us. And that's all it took to make our job system, or to make our VFS asynchronous using our job system. So it was pretty straightforward stuff, I think. Thank you for the follow, by the way. Appreciate that. Barely used Helix, can never leave behind my macros and regex replace. Yeah, that's the thing. Like, I'm so used to Vim and being able to configure it, and frankly, being able to write whatever I need it to do in scripts. If I don't have it here, that it'd be hard for me to leave it at this point. All right. So that is that item. So the next thing that we're going to work on tonight is removing the resource system. And we are actually going to start off with, let's see. This is where we were actually crashing, was in the static mesh system. So I'm going to start with the static mesh system, removing that out of here. And using, instead of the resource system, we are going to use the assets directly. So I don't think this is going to require a whole lot of fanciness, to be completely honest. There's just a few things that we need to set up, and then around asset loading, and I think that's really about it, right? So we have all this on resource loaded stuff. One thing I do need to look at is resource handler static mesh. And I think if we take a look through the code, I think all this does is basically take a copy of everything. Maybe it looks like it does. That's just validation on the request. Let's see. Yeah, essentially just so essentially just requests that, and then we already have this updated with our new system, right? So we can essentially take this code right here and use it directly in our static mesh system and dispense with all of this stuff, right? The release is probably something we should look at, because this does do some stuff in the render buffer. Let's see. Interesting that the request didn't do that, but the release actually does. Oh wait, yes it does. Okay. So here's where we do all of the uploading of the data, right? So we're gonna use some of this logic. So it's gonna be just a little bit of moving some stuff around. Not a huge deal though. All right. So let's see. How do we want to attack this? So the whole resource loaded thing, that's going to go away most likely. I don't want to delete it just yet, just in case there's anything. Let's see what else needs to be in here. So this is where we request the material instances and we process our submeshes, which actually all that is requesting material instances for our submeshes. Okay, so that can stay there for now. We are going to need that logic too. So render data generates. Okay, that has to do with rendering directly. That is fine. I think so. Our static mesh system works with static mesh instances, right? And so if we remember, this is a little bit different from some of our other systems. So static mesh instance has a pointer to a mesh resource, right? Which we probably ought to change that. And then it has an array of material instances, right? So I'm actually thinking, similar to what we do with textures, instead of having this, right, where we pass around this pointer everywhere, which is kind of ridiculous. I'm thinking for the instance, we just have an ID of the underlying resource, right? And we can refer to that directly. So the reason that we have different instances of this, right, is because of the material instance. If we didn't have to have material instances, we wouldn't really have to worry about this. So the reason that we want to have this is if we have, let's say we've loaded the same static mesh twice, right, in the same scene. We would use the same underlying geometry, right, but each material would be unique. So if we wanted to apply an update to one of those material instances, but not the other, we can do that. And so that's why we have the static mesh instance. And so basically that just links a static mesh to a material instance. One of the things that we can override incidentally is tint. Eventually there'll be other properties, but that's just kind of the one that we can do for now. So I think instead of having this k-resource static mesh, I'm going to call this a k-static mesh. And let me actually go to texture system really quickly, because I don't remember where I actually did. Where did I put the type def for that? K-resource types. Okay. So I think we're going to do the same thing. I think we're going to do the same thing for a static mesh, right? Let's see. Right, so we have static mesh. So all of this submesh stuff, like the submesh, the mesh itself, all of this stuff really. This is all stuff that we don't really need to be exposed, right? There's no reason to have this out there. If we need this data for some reason, we should be able to query for it. Even the submeshes itself should really be, it's just geometry and a material name, right? Which we could argue maybe this doesn't even need to be done this way. So maybe we think about the way that this is kind of done too. But let's see. Let's do a k-static mesh, right? We're going to say represents let's actually just do this. Represents a single static mesh which contains geometry, right? And so essentially what we're going to do is we're going to replace everywhere that has this sort of k-resource static mesh thing with just this, right? And then we're going to reference that by ID. I don't think we're ever going to have more than 65,000 of these loaded. So I am okay with leaving this as a U16 for the ID, right? So this essentially becomes an ID, which we pass around, and then the static mesh system will be reworked, similar to how the texture system was reworked to allow us to reference that by ID. So I'm going to take all of these, and cut them from this file and go back to our static mesh system. And let's see, let's paste these here. And we're going to put a to-do, remove this old stuff. Because we're going to rework the way that all this stuff is stored. But I need somewhere to put this for reference right now as to what we're holding on to, right? Okay. So in the static mesh system H file, let's determine what all we need and what we don't need. So the mesh resource, this is just going to be a k-static mesh. It's no longer going to be a pointer. And then we're just going to say, we're actually just going to say mesh, I think. And this is going to be whoops, the underlying mesh, not even resource, right? So let's see, represents an instance of a static mesh resource. This is, oops, actually get rid of the word resource. This is to be used in the world as opposed to actual resource itself, as opposed to, actually we'll just say meant to be used in the world. Material instances are obtained when acquiring this instance, this static mesh instance, and released when releasing this static mesh instance. There. Okay. Now, we have this instance ID, which we're no longer going to need because this is our ID, right? So this, well, actually, wait a minute, though. That's instance ID. Well, it doesn't need to be randomly generated, for one thing. I would say, instead of randomly generating the instance ID, do we actually even need an instance ID? When we issue an instance, the only thing that has is this and this. So if we pass this instance to be released, what do we need this for? I would argue nothing. Let's simplify it a little further. Make the structure smaller, right? Okay, so we have material instance. That we do need, so that's an array. Material instances. I would actually argue that this probably... Let's actually do this instead. So we don't need material instances, right? Let's take that. Let's take that and put it, I don't know, here for now, right? I'm going to stick it in a struct for now. We're not going to keep this, but just as kind of a reminder of what it's for. All right. So instead of instance ID, I guess let's make this a U16. Oops. Right. And this is going to be the identifier of the instance. And I think what we'll do is we'll have separate arrays of instance data per mesh. And then we will manage that instance data within that mesh. And then we also, I'm not going to keep the tint here either. We could manage that internally. So I think the only thing our static mesh instance should hold is these two things, right? And let's go with, let's keep our naming consistent here, right? So we'll have a K static mesh instance. All right, I think that makes sense. Do we want to call this K static underscore mesh or K static mesh all one word? 532nd or something. Yeah, probably Spiro. Well, I don't know. I mean, you were probably 32nd because there's 33 viewers right now from what I can see. But welcome. Thank you for being here. I appreciate it. The Giga Chad over there. For those of you who don't know him, by the way, Spear's always doing Giga Chad stuff over there on Twitch. He reviews a lot of tech news. That's kind of his thing lately. And it's really informative and good to watch. It's very entertaining as well. But he also does a lot of dev over there on his channel as well. Most specifically, he is working on a game that its engine is written in C, and it uses the HTML DOM as its renderer. So yeah, it's really interesting stuff. Out of the box thinking, love it. Go check him out. All right, Layla over on the YouTube side, hello. Singy, good to see you as well. Syed, good to see you as well. Hello, I hope you guys are doing well over there. I kind of don't like the way that this looks all one word. I think I'm going to keep it K-static mesh. I think that's fine. Okay, let's do that. And let's see, we'll go back to Didn't we actually have I thought we did. We don't have a K resource type name for this. I guess we don't really need those anymore either, though. So those things are going to go. But we'll focus on this for now. So I guess when we really think about it, the only thing that we really need for an instance is a mesh and an ID. From this, we can look up anything we need, right? And this is just a nice small structure. So I think I'm pretty good with that. As far as some other stuff, I guess we should probably talk a little bit about naming, right? So we do have some render flags here when it comes to rendering these things. So let's go ahead and fix that. It looks like we also foobarred the name of that. So let's fix that. Let's see. Why is this bleating? Redefinition of K-static mesh. Really? Wait a minute. Where else is that defined? Really? Aside from right here? Oh, we have it on render types. That actually makes more sense that it's there. Okay. And we have the flag bits as well. Okay, so we don't need either one of these actually then. Cool. Even better. All right, so now we have static mesh, submesh render data. Do we even use this? Do we even use this? We already have a new type over on render types as well, core render types. I suppose we could use that one, right? It does have flags, vertex data, and index data, as well as material instance. Yeah, we should probably use that one too. I must have started refactoring this and then just never finished it. Cool, more code to delete. Static mesh render data. Let's take a look at that. Yep, we have that too. And it looks pretty much the same. Okay. All right, so we're going to delete this too. So this is the only actual type that we need for the system, which is actually pretty nice. I think that's probably the way that it should be. All right, so let's take a look at our API. So the first thing that we have is static mesh system instance acquire. So this requires the state, resource name, and package name. Okay, so this is probably not the way that we want to do this, right? Although we could, right? So I think in our texture system, let's try and make things a little bit consistent here. So we would acquire based off the image asset name. And then I think we also had, we had from package variants of that. So this kind of mimics the way that the asset system works a little bit, just to kind of make it a little bit clear as to how it works all the way down. So instead of saying resource name, I can close this buffer. Instead of saying resource name, we'll say asset name, right? And this is going to be acquire from package. If I can spell from correctly. There we go. So we have asset name, package name, and then we have out instance. Instead of doing the out instance thing, let's return that. Let's return one, right? Because now it's just a flat struct. It doesn't have like pointers or anything in it. And then, when we acquire this, we've acquired it with, these things already filled out. Whether or not it's loaded right away is irrelevant. We can handle that internally, but we don't have to necessarily worry about that in user code. So when we go to release one, though, we do need to take in a pointer to that static mesh instance, right? Because we want to invalidate what is here in the pointer, or in the structure, right? So when we're creating one, we can do it this way. We can actually have an alternate version, right? And this is just going to be acquire, right? And then without a package name. And so what this one will do is it will take in, or it will assume rather the application's package name, which means we probably need to provide that. So we do have this static mesh system initialize. However, we don't actually have a config for this, unlike most of our systems. So we should probably define one of those. I guess I'll put that here. So we'll type def a new struct, and we'll say static mesh system config. And we'll do static mesh system config there. And what we'll do is we will take I believe we're going to want this in string format. So we'll say, well, you know what? I'm not going to do it in string format. I'm going to do a kname because I don't want to have to worry about string lifetimes and all that crap, cleaning them up. So let's take a kname and we're going to say application package name, right? We'll take that in here. So this will be static mesh system config. All right. And so we'll work that into the state as well. Okay, so we have instance acquire from package, and then instance release. And then we have the generation of render data. So this is going to be a k static mesh instance, and then k render flag bits, and then let's see the render data. So yeah, I guess we're going to use the k version of that as well. And then we also have something to destroy the render data, which I'm not sure if that's completely necessary, but we'll have it anyway. And so I think that is all that we really need for now. We can add other stuff like getting the submesh count or getting the name or getting this or that, or setting various things. Tint, I guess, would be an example of that, right? So I guess we could put an example in here of that. So we'll have KAPI, we'll have a Boolean return. We'll say static mesh, and we're just going to say static mesh. In fact, we're going to rename all of these, I think, to do that. We're going to say static mesh tint get, right? Yeah, let's do struct static mesh system state, and then so the tint is going to be a vector 4 out tint, right? And so it'll return true if the, whoops, actually, might help to actually provide the instance, right? So we're going to take a constant pointer to the instance, k static mesh. Actually, you know what? That structure is small enough. That structure's small enough, I'm just going to pass it as it is instead of taking a pointer, right? So we'll say k static mesh instance. And then, of course, we have a get. So we'll have a set as well. And then this will just, instead of taking a pointer, we're just going to say tint, right? And so that's the way that this is going to work, and then it'll manage that data internally. So instead of passing around a structure all over the place where, you know, it contains all these properties and stuff that we're never actually going to use 99% of the time, this is kind of the way that we're going to interact with those things. And I think that makes sense, right? So we do need to rename some of this stuff. We have in here static mesh system, which frankly, it doesn't need to be system anymore. So we could just say static mesh instance acquire, right? Static mesh instance acquire from package, instance release, and then, you know, render data generate, and render data destroy. And we actually don't need this to be a pointer, right? And actually, this is actually going to require, though, that is going to require the state. Okay. Let me see. K-static underscore mesh seems odd, maybe just me. That was the thing, like, I couldn't really decide on the naming. Because K-static underscore mesh seems weird, but I feel like this feels weirder. K-static mesh, all in one word. I feel like that's just a little bit less readable. Let's see. Nilsson, how's it going? Question, do you separate dynamic static meshes by using different structs or have a flag like is dynamic? I'm working on mesh system myself. Love to hear logic. So right now I only actually have static. We're going to be adding, by dynamic meshes, I assume you mean like animated meshes. We're going to be adding that a couple versions from now because we actually have to add animations. Now there are going to be other things that potentially can be edited dynamically, but I think the way we're going to handle that is a little bit different. So a static mesh is basically something you just, you import it into a scene and just kind of use it. For something that's a little bit more advanced, specifically I'm thinking of like dynamic geometry would be something like editing terrain, for example, editing a terrain, a height map terrain. That would be handled completely separately. Yeah, I wouldn't want to do it. I don't know that I would have a use for like a dynamic mesh. Because the whole point of a static mesh, at least the way that I'm structuring it, is a static mesh's data doesn't change often. If it does change often, it's probably either going to be like an animation, like a skeletal mesh or something like that, or it's going to be some other sort of specialized geometry that we probably need something like a different, completely different struct for. And it would hold completely different data. So, Trash Can, how's it going? Good to see you, buddy. How have you been? Let's see. Hi, I downloaded release v10 recently and found. Testbed after you load the scene. DRA memory types, kallocate free. Yeah, so don't use version 0.10 right now. It's not like fully released. It's like the current it's the currently targeted number for release, but like we're still working towards that release. So I would not use that version yet, because we are drastically changing some stuff. So the version that is checked in on Git will basically run, right? It'll run this, but if you try and load anything, it poops itself. Just because I'm currently in the works of, re-evaluating this. So, yeah. I would say don't do that. All right. So, I think static mesh system initialize and shut down. System, I think that's fine. Okay. I'm pretty happy with the way this looks. So I think this is the API we're going to stick with, right? This is how we want to use it for the rest of the system. So we don't use static meshes directly. We use an instance of them, right? And that's made pretty obvious by this here, right? There's nothing in the API really that takes a static mesh directly. That's basically just something that exists. So if we have to query it for something, we have it. But yeah, everything's fine. How about you? Not too bad. Can't complain. I appreciate you asking. Yeah, I'd taken a week off just because I kind of needed a break. I was dealing with some other stuff IRL, nothing bad. And I just kind of hadn't taken a break in like months on end. So, I took last week off, but feeling refreshed as a result. So it's always a good thing. All right. So let's start reworking this step at a time. Okay. So the first thing that we're going to do is obviously we're going to take in this config because we added that. So static mesh system config. That'll bring that up to date. And then essentially, let's see, we have state dummy, right? Which was apparently we didn't really have a state. We're about to change that big time. So we have kname. We're going to do application package name. All right, so that's the first thing we're going to do. We're going to take that application package name from config application package name, right? So we're going to take a copy of that. And then we are going to store essentially what is in some of this data here. Instead of storing it in structs like this, we are going to store it in our state, right? So we're going to basically eliminate all of this stuff and have it in our state instead. So there's a couple ways that we could go about this. And I really want to think through the state before we go refactoring the whole system, right? So we needed to get this piece in. That's good. But we may need to add some other things for config as well. So we could store an array of static meshes, right? And if we have, if we think about, this K resource base thing, we could potentially, store a lot of this type of information there, but I don't think we need most of this either. Like the only thing we could foreseeably see is maybe the name out of this, right? That's the only thing I could foreseeably need. Maybe K resource state. Actually, that's probably something, right? But we'd have probably our own state for static mesh, right? We don't want to really use this K resource state, I don't think. because that's another thing I'd like to eliminate. So, we don't really need this base. We could argue that we need kname name, sure. We could argue enum k static mesh state, right? We could say we could say uninitialized, right? We could say loading and loaded, right? Those are the only foreseeable states that I can think of, right? So we'd have, k static mesh state, right? And that's going to be the state that the mesh is currently in. So essentially what would happen is uninitialized would mean this sort of slot is free to be used, if you can kind of see the direction I'm going with this. And then loading is basically we've kicked off an asynchronous asset request to load up a static mesh asset. So that has not yet returned, right? And so this will be marked as loading until we receive that asset back as loaded successfully. And then also we upload it to the GPU. And at that point, once all of that is done successfully, then we would flip it over to loading. And then when we go to unload one of these, or release it, rather, and we don't have any more instances of it, as it were, then we would basically just unload everything and flip it back to uninitialized, right? And that's essentially it. So we don't need any more than 3 states for that. If it was just 2 states, I'd probably just use a Boolean instead, but this is a little bit more flexible and allows us to expand this if we did so desire. So each mesh would be essentially this data here, where we have a submesh count and submeshes. So there's a couple ways that we could handle this. The submesh, we should probably take this. Actually, let's take this. We want to keep this. Let's put that up here. Need that. So the submesh basically has the geometry and then the material name. And to be completely honest, I don't know that we actually need to track this. We could track the geometry, but we probably ought to track like the actual material as opposed to just the material name, I'm thinking. No, we need the name because whenever we do an instance of it, we need to actually load the material by name. Okay, never mind that. Also, this request info, this structure can go. Static mesh instance. We probably do want to hold on to that because that we have material instances. But that's really the only thing within a static mesh instance, I believe. So, realistically, what we would have, and this is kind of one way of storing this. I don't think I'm going to store it this way, though. I think I might do a structure of arrays instead. And then maybe split these 2 things off to something like this. So we'll have maybe a type def static mesh submesh data. We'll go with that for right now. Right? And so these 2 would go up here. And then we have static mesh submesh data. right? And then maybe we have, I guess we could do submesh data, right? So that we have just, sort of a flat structure of things, right? So we can turn these into arrays that are then indexed. So we can eliminate this structure by taking these guys, going into the state, and placing those here. So this is going to be, names, and then states, and then submesh datas, right? And so all of these will be indexed by that ID that we've been talking about, right? And so maybe we'll also have, U32 mesh count or something, right? And so this will be essentially the size of all of these arrays, right? And so, it'll be very quick to go through and just look things up by name, or look things up by, in fact, we could probably do something even a little bit more fancy with the name. Or, we can zip right to the static mesh state, or zip right to the submeshes for a particular static mesh. And then we have the instance data that we have to think about as well, right? So, get rid of that. So we have our submesh data here. And then this actually has submeshes, right? So this actually contains, do we want to call that submesh data? Maybe we just call this submesh, right? Because this is a structure that's only in here, right? So maybe we just do that. So we have submesh data that holds account and submeshes. We could argue if we were to use a D array, we would kind of get this for free, right? But we don't need the overhead of a D array because this number of things isn't going to be changing. Let's see. Oh my gosh, is this Neovim and Arch? Yes, it is. What's going on, Coffee Lava? It's been a minute since I've seen you. How have you been? Did someone say Arch? I'm on Arch, by the way. Yeah. Arch, by the way, down here. I named my machine Arch, by the way, just for the memes. I had to. It was either that or I had to name it ECS or OOP, and I didn't want to do that. You're getting fried with the heat? I think that's pretty much everybody at the moment. I know it's been pretty hot here too, and it's just getting started. How about you? Stop the game design for now. So, we're basically going back and forth between game dev and engine dev. And so, because this is a brand new engine, as I start using it, I'm just like, you know what? This API sucks. I'm redoing it. Or, hey, this thing didn't work. Let's change it over to this and make it a little bit simpler and easier to use. So that's kind of the phase I'm in now. Is I've done a little bit of game dev, and I'm like, you know what? There's several points of this that just don't really work very well, or it's going to take too long, or it just doesn't feel right when you're trying to actually write game code. So I've gone through a lot of effort to simplify the process of loading assets even further. And now I'm kind of doing that with various resource types. I've already done it with like textures and stuff. And I got my asynchronous asset loading working again. So it's just kind of stuff like that I just kind of am going back and forth between. So I actually have on the roadmap, I have a few different things that I want to do. And I might combine some of these into into a single release. But this is the release I'm working on right now, which is 0.10. And so I refactored the texture system to make it a lot easier to use. I refactored the asset system to make it easier to use. And I jobified VFS loading. So I'm also going to rework the import pipeline to make it, again, easier to use, and get a lot of that logic out of the engine because it doesn't really belong there. And then I'm completely removing the resource system that we put in place, and I'm diverting all that logic to the individual systems that use those resources. So we're going to remove, again, a lot of code. And I'm going to rework hot reloading. So that's all the stuff that we're doing in this release. And then I've also determined that the scene is going to be moved out of the engine as well, because we were trying to make like this generic scene, and we tried a few different things with like different node systems and different attachments and all this other kind of stuff. And then I was like, well, maybe we should make it a little bit less generic. And then I got thinking about it, and I'm like, you know what? What knows how a scene, or what a scene is, and how it's supposed to be constructed, and what is in a scene? The game knows that, right? The game code knows that. So instead of making a super generic scene, I'm pulling the scene out of the engine, making it super game specific, making the scene in the game code, right? Because it knows what it expects. It knows the type it's going to deal with. If I need to extend that, it's easy because it's all in the game code, right? Outside the, base types. And so I'm basically going to pluck the scene logic out of the engine and put it in game code. And then, get all of the references out of the core engine. And then I'm also going to remove the render graph. It was cool. It was experimental. It's overhead I don't really need. So, if you guys wanted it, it'll be there till version 0.12. But it's just another one of those things. I'm like, you know what? Again, the application has to configure that, right? So, like, if the application knows how the render process is going to work, why not just have the application drive that in code? So that's kind of the direction that we're going there. We're also going to remove some legacy systems that aren't really doing much of anything, like the lighting system and camera system. There's not really a whole lot that they're contributing, so we're going to clean up some more stuff there. We're going to do animated meshes in 0.14, and then we're going to circle back to the game. Better to be specific than super generic. Yeah. And part of the point of this whole series is to try stuff and see what works and what doesn't, right? And then examine the results. And if something doesn't work, we pivot. And so we tried those various things. We tried being generic, and we saw the issues with that. And so we're pivoting away from that and going game specific, because frankly that kind of stuff is game specific, right? So and what I'm doing here is I'm basically pulling apart the tiered resource system that we had, and I'm splitting all of this out to be essentially it's going to wind up being a structure of arrays, and then we just pull everything up by either instance or the mesh directly, right? A mesh instance or an instance. So what we actually have here, so static mesh instance, if we think about an instance once again, there's going to be a few things that we need to know about a static mesh instance. One of those things is, of course, going to be the k-static mesh base mesh, right? The mesh that we're basing the instance off of. And I guess we could rename this to that, right? Oh, do we already have that somewhere? We do. Where did I... Oh, that's right. We put it here. This should be... Let's do... Because this is an internal struct. Why don't we just do instance data? Right? And then this is going to represent all instances. No, I'm sorry. This is going to represent instances of a particular mesh, right? So we're going to have instance data, and then we'll have instances, right? And so this one will be instances for the mesh indexed by k-static mesh ID. Hang on 1 second, guys. Having some networking issues I just have to figure out real quick. Bear with me with just 1 second. Are you guys seeing bitrate drops for me or no? I'm not seeing anything. It looks fine. Okay. You haven't had any buffering? Okay. All right. Yeah, I don't know what's causing it then. My wife is raiding in the other room, and she's apparently getting some lag, but I don't think it's our internet. All right. I missed your second question. Let me see. Oh, you're right, I did. 1 second. What would be the best location to store mesh transform? Plan to write an ECS system, but right now everything is bare bones. I would say, would it be okay to transform? Would it be okay to store transform within mesh right now? I did that for a bit. I don't recommend it. I would keep transforms separate for from your mesh. You could maybe have an array of transforms right next to it or something, but like transforms are going to be used for stuff outside of just meshes, so I wouldn't pair it together like that if I were you. Thank you for the stretch redeem and the posture check. I'm a little behind on my notifications. I have a doubt. You don't use any dependencies, right? Is it actually worth it? Yes, it is worth it, for sure, because I have complete control over what I'm doing. It's not necessarily that I don't have any dependencies, right? I still depend on the OS, and I still depend on GPU drivers, and sound drivers and things like that. But yeah, having control over that stuff is definitely worth it. Absolutely. All right. Baguettes, how's it going? Good to see you. 3x floats per position, 4 floats per quaternion. Yep. Question is not what, but where. Yeah. Transforms are usually per entity or whatever references them. Yeah, if you're using an ECS, that's one way to go. A lot of game engines will actually put the transform on the entity as opposed to like having it as a freeform component, which I think is a bit of a mistake, because I think that and this was actually one of the things that we did initially in our node system, is that you don't necessarily have to have a transform on every single entity in the tree, right? If you're just using an entity to group things together, but you don't necessarily need them to be grouped by transform, you should only really have to add a transform where you actually need it. And if you split the transform out to its own component that you can attach to an entity, or you could attach it to maybe another, you could attach it to a component that way potentially too. That would be a whole lot more flexible, I think. So I would not store it as part of the entity. I would not store it as part of the component. I would separate it out and have it be its own component if you're going that way. Trying to build an engine with STL3 as the base and hopefully swap out STL3 once I have a game. Swap it out to what though? Because if you rely on it too heavily, that's going to be really hard to do down the road, unless you abstract it really well. Like OS dependencies and stuff. Okay. But are you planning on using like their rendering API, or are you going to roll that stuff on your own? Because like that's where it would really be hard to swap out later without, completely rewriting it. Okay. Right now I just use their stuff to draw rects. It's probably only going to be a 2D engine. Okay. So I would say get away from that as soon as possible. Like use GL or something if it's going to be super simple. But because if you rely on it too much, like the more hooks you have into their system, the harder it's going to be to get away from it. So I hope that makes sense. All right. So our instance data will be set up this way. Inside of our instance data, we're going to have well, I guess we don't really need the base mesh, right? Because we're going to know that from the index. So I guess we don't really need that. We have material instances, which is an array of material instances. It's going to be associated with the submeshes. Okay, so I think that's fine, because we can actually get the submesh data from, let me think about this for a second. So we have one material instance per submesh, potentially. Right now, those two things line up. So we have a submesh here, submesh data. I'm wondering if we should like collapse some of these things into well, this is part of the, no, I guess we can't. Okay, I think this will be fine. All right, let's see, asset request listener. I don't think I need that actually, at least not, I think it just needs to be as k static mesh. I don't think the instance, I think the instance we actually don't need. I think it's just the base mesh that we need. All right, so if we have, Oh, if we do have to do a lookup from instance data, though. I don't think we have to. All right, it should be fine. Okay, so my thought is, these are all indexed by the static mesh ID. So we have the submesh datas, one of those structures, which is this guy, which in turn has its own submeshes, which each one of those has this. And then we have instances right next to that for that particular mesh. Yes, okay, I think that's gonna be good. So the next thing we need to think about is, how do we want to set up these arrays, right? Now, probably the way to do this is going to be, we start off with some number for mesh count, and then we increment that number once this gets full. Give ourselves more room in the array, so to speak, and that's what we use to store all of our mesh data in, right? So I think it'll essentially just resize all of these arrays, which I think is going to be fine. So let's set that up first. So set up, how do I want to say this? Set up data arrays, right? So we want to do state, and then we want to do mesh count. Oh, wait a minute. Let's start off with like 64, but it shouldn't be called mesh count. We should probably do max mesh count, right? The max number of entries in the below arrays can be increased. Let's be explicit about that. Okay, so we're just going to start with 64, and then I think what we should probably do is put in like a function in here to say that we want to increase, or I guess ensure array allocation, right? So we could say, I guess we could do static void ensure arrays allocated, right? And we'll take the static mesh system states, and then I guess we could do, actually that's all we need is the state, right? So this expects count to be, or actually expects max mesh count to be increased before called. Maybe not actually. Let's actually do this. Let's say, what was that, U32? Yeah, let's do U32 new count, right? And the reason I'm saying that is, because we will need to actually do a data copy on all this stuff before we actually resize. So if state, and then I guess we could do if state, and then I guess we'll do these by order. We'll say if state names. Then what we'll do is we will kalloc type C array, and the type is going to be kname, and the count is going to be new count, right? And then k copy type C array. The destination is going to be, whoops, I didn't actually. Okay. Let's do kname temp, right? The destination is going to be temp. The source is going to be state names. Actually, we want to do that first. Yeah. Okay. Type is going to be kname. And it's going to be, we're going to use the old count, right? So we want to use state max mesh count, right? So actually we want to know if state max mesh count and state names, right? So then what we do, so we take a copy, we create a new array. Either way, we're going to be creating a new array. If the array already exists, then, oh, wait a minute. Yeah, if it already exists, then we take a copy of what's there right now and move it into temp, right? And then we need to free type C array, right? And we're going to do state names, right? And then the type is kname, and the count is state max mesh count, right? And then down here we do state names equals temp, right? And obviously we want to reuse temp, so we'll block it off, right? And we'll essentially need to do this with each one of our arrays here. I could probably macro this and make it a little bit easier, but oh yes, Lecheraggio, I've read that article before. Yep. Thanks for the advice. I wasn't sure how easy it would be, but I'm focusing on the architecture and abstractions. I've had the same game for 3 days, just moving some calls around and stuff. Yeah, so, I mean, that happens sometimes, right? You gotta refactor and stuff. Rendering part is very complex. I struggled so much just to understand the architecture and how to make your own renderer on top. Literally years off and on. Yep. Would have already done some games probably, but if you have the motivation, go that path, dive in. At the end, you'll feel like a wizard doing magic. Probably. Yes, that's true. Absolutely true. Whoa, Mudbound Dragon raiding with a party of 15. Thank you so much for the raid. What did you get up to on stream? Welcome, raiders. If you're not following Mudbound Dragon, do it. Are you still working on the Pico stuff? The Pico game? If I recall correctly. Just did a bit of Pico 8 work again tonight. Yeah, okay, I was wondering about that. Yeah. It's going pretty good here. We are refactoring one of our systems to, believe it or not, we're going to wipe out a bunch of code by doing this. So we're actually kind of in a process right now where we're like trying to simplify, batten down the hatches on stuff, and eliminate a lot of unnecessary code, which is always nice. Did some AI refinement. Awesome. That's always fun stuff to work on, for sure. Very nice. Well, welcome, raiders. For those of you who are new here, I'll give a 2-minute synopsis of what we're working on. So what we're building is something called the Kohi game engine. So it's a game engine written from scratch in C, using Vulkan as our initial rendering backend. I say initial rendering backend because we plan on supporting Metal and Direct 3D as well. And so it was essentially, it started off as a YouTube tutorial series, quickly outgrew that format. We changed and tried a bunch of different things until we kind of landed on this live stream format. And thank you for the subscription over there on the YouTube side. Appreciate that. And essentially, we wound up on this live stream format that you see here. And so this is meant to be sort of an educational exercise. It's on a way, basically, to build a game engine. It's not the only way. It's not even necessarily always the right way. we try a lot of different things in here, and some of it works, some of it doesn't. And when it does or doesn't, we do a deep dive into why that is, and then we refactor that, right? Part of the real process of developing stuff is refactoring stuff and trying things out, and seeing all of that. So the live stream format allows me to do that, as well as sort of explain my thought processes along the way. And so that's kind of how we landed where we are. We do simulcast to YouTube and Twitch. The game engine itself is available in Windows, Linux, and Mac OS. It is early days, though, so I don't recommend actually using it until we complete the first game that we're working on. Back to that in a second. The engine itself is free and open source, so it is available on GitHub. It is Apache 2.0 license, which means you can use it however you see fit. Whether it is commercial or personal does not matter. All that I ask is that if you use it, you say you used it. That's literally it. This is meant to be an educational exercise, so everything having to do with the engine will always be open source and will always be free. I don't paywall anything on this channel having to do with the engine. And I never will. I believe that, educational stuff should be free and freely available. So that is here. The only sponsors that I have are you guys, basically, right? And so there's, a README with a couple screenshots. We've kind of got things taken apart at the moment, so I can't quite, demo it at the moment, but that's the engine portion. We have started development on a game. It is called Shadows of Illumina. I don't have any of this stuff up at the moment, but it is a 3D action, isometric action RPG. And it's basically going to have a non-linear storyline. It's going to encourage exploration. And it is going to be a fully 3D game, as I mentioned. So that is the first game that we are making with this engine. So the overall process is we're going to be bouncing back and forth between engine dev and game dev, especially here early on where, the series is just now kind of getting to the point where we're starting to do some game dev stuff. We're going to discover some stuff that doesn't really work all that well, or maybe some APIs that need simplification, which is what we're doing now. So we're going to be bouncing back and forth between engine dev and game dev, and towards the end, we're going to be focused much more on game dev than engine dev. But yeah, that's kind of what we're doing now. We are actually, as I mentioned before, we're in the process of removing more code than we're adding. So I think, let's see, do I have... Yeah, so just to give you an idea, pull this tab down. So this is kind of comparing our release, I should say what's in our current release branch to the refactor branch I'm working on right now. And there's been 4,000 additions and 12,000 deletions, right? So we've deleted a lot more code than we're actually adding, which is cool. All right. So we've refactored our asset system to make it a lot easier to use. That is done. We also got our virtual file system working with our job system to make that asynchronous, which is also done. And so now what we're doing is we had this sort of generic resource system that was sort of in the middle of the systems that use those resources and assets, and we're removing that layer. So we're yet going to simplify more code. Jeet, how's it going? Good to see you. Welcome. All right. Let's see. So I think we could probably macro this. So this is essentially just a resize of all of our arrays for our mesh data, right? So I think we could probably just, I think we can macro this, right? So let's take this. Actually, let's take all of this. And let's go up here. And we'll paste that, and we'll do define. And we're going to call this, let's see, resize array, I guess. Yeah, should be fine. All right, so that's going to take in, let's see, we want the What all are we going to need? We're going to need the array. We're going to need the type, the old count, and the new count. I think that's it. Okay. So we're going to do backslash. Actually, I think that should be good. And so this is going to be type. And then we have, just type in here a couple more times. And then, let's see. So, oh, this is type as well. So new count is there. That is looking pretty good. So we want old count. We want old counts and old counts. And then we want, let's see. We want array for this. And then here. I think I've got that right. So instead of all of this for each one of these things, now we can do resize array. The array is going to be state, names. The type is going to be kname. The old count is going to be state max mesh count, and then the new count's going to be passed through there, right? And so this should, I'm going to put it below this for a second, should expand to exactly what we have above. And of course the preview window went up instead of down. Perfect. There we go. All right, so we should have kname temp, kname allocate. Okay, this breaks it all the way down. All right, that's fine though. So we allocate to the new count. Let's see. Okay, that looks good. Yeah. Okay, I think we're good. All right. So instead of doing all this, now we can just do that, right? And I can take this and do, you know, I probably ought to put this right next to these guys, I think, actually. Let's do resize array. Pretty sure I've done this in a few different places too. Okay, so I'm going to take all of this and go here. And let's see. This is going to be resizes the given array of the provided type. Also copying the contents of the old array to the new. Performs a new allocation, so the array address will be different. Different. Oh my god, I can't spell different. All right. Note. New count must be greater than old count. I suppose we could assert that. Do we have assertions here, though? I don't think we do. No. And I really don't want to add it. I don't want to add logging to this either, because that's not really... That's fine. All right. We put a note there. All right. That's better. All right. So let's see. We need a couple of those. The next one is going to be states. The type is going to be k static mesh state. And then we're going to do submesh datas and static mesh submesh data. And finally, instances is going to be instance data. All right. So all we need to do now is we can say ensure array is allocated, pass the state, pass the new count, which is 64. And then what we can do is whenever we go to add something to this, if we hit a state, which by the way, uninitialized means this slot is unused, right? So if we hit, if we don't find one of these that's available, in other words, in the uninitialized state, then what that means is that the array is full and needs to be resized. And then all we have to do is essentially grab whatever the current max mesh count is and call this function, right? And yeah, we'll okay, I skipped a step. Figure out what this is, multiply it by 2, and then do it, right? So we're starting off with 64. I know that's a bit of a magic number, but you know, that seems like a reasonable number to start with. The other thing I want to do is this static function doesn't belong up here. We want to move that to the bottom of the file. So let's take that down here. All right. So I think that's actually all we need to do for setup, right? That's going to handle all this stuff. Cool. All right. Shutdown. So shutdown is actually going to do a bunch of things. It's going to have to free those arrays for one thing, but it's also going to have to make sure that all of that stuff is unloaded. So it's going to have to actually scan those arrays, look for meshes that are still considered loaded. Well, I guess we really don't have to unload them. Because if we're shutting this down, I don't know that we have to do any of it, to be honest, because we're dealing with our own allocator here. Like, I don't know that we actually have to do anything with this. Because all the mesh data is all uploaded to vertex and index buffers, which are all managed on their own by the renderer. So I don't think we actually have to do anything there. Let's see. I don't think I'm going to be able to catch up on all the chat, but is there any AAA game written in mostly C, or everything C++ when it comes to AAA? Most things these days are probably C++. Unfortunately. Yeah, there's a bunch of reasons for that, but yeah. Also, my 5 cents of the render graph topic. I thought it's a large, complex system. It's hard to... Wait. I thought it's a large, complex system, hard to integrate, but it is the solution to shader dependencies workflow. It was quite shocking to hear you say you're going to remove it later. but I understand your engine is quite niche and doesn't present itself as a huge generalized mess of it all, everything like Unreal or Unity. Yeah, exactly. That's what I'm trying to avoid. More generality, more friction, more interconnection work, etc. The simpler, the better. Leave it to users, devs control. So yeah, that's the way that I'm going to go with it, right? Because the render graph is cool, right? And we have, if you want to set that up, we've got like an entire series and an explanation how we did it and why. And it's really cool and it does work, but there's a lot of overhead that comes with it, right? We just don't really need it. Like the application understands how the rendering should work, so why doesn't the application just do that, right? Let's see. I use C++, but the code is 90% C. Yeah, that's the way I write C++ too. Okay. Let's see. Okay, I think I'm caught up now. So we don't have anything to do there. This is just going to be instance acquire. Let's actually just do, let's just take this definition, right? Instead of trying to refactor, let's just do that. Asset name in this case is just going to be, let's see, we should probably do, you know what? We should probably do the package version first because the non-package version is just going to point to the package version. And what I mean by that is literally right, we're going to have this, and we're just going to return static mesh instance acquire from package. Pass state, the asset name, and then the package name is going to be state application package name, right? So it's just a little bit of a convenience there, but that's all it is. And that way all of the logic passes through one function. And then release, let's go ahead and just update that function signature as well. And we'll get to that in a minute. So this is where like a lot of the meat and potatoes of this stuff is going to be done. So right now this reaches out, and this is one of the things that I'm talking about wanting to simplify, right? Like you have to do all this crap just to get a resource. It's kind of insane. So I think what I'm going to do is probably, let's see. Yeah, I'm probably going to go through and write all the code here, and then the things that we need to split out into different functions we'll split out afterwards. So we'll have to split this up into like a few different steps here, right? So the first thing that we need to do is find a free slot and use it, or expand the arrays and use the first available from the new array, right? So to do this, what we're going to do is we're going to do for, and then we'll do u32i is equal to 0, I is less than state, and we have max mesh count, and then plus plus I, right? And so what we're going to do here is all we're going to check is we're going to say if states sub I equals, and then we have k static mesh state uninitialized, then found a free slot. Let's see. Thank you for the follow. Appreciate that. I think C truly has one of the simplest and easiest to understand syntaxes out of any programming language. Yeah, I wouldn't disagree with that. Yeah. It's pretty good. There's a reason I like it. All right. So I think what I might do here, I think I'm going to do a kassert debug. Actually, let's do a kassert message instead. And we want to make sure that state exists. State is required, you dingus. Okay. And then we can get rid of this. All right. Okay, so found a free slot. So what is a free slot, right? A free slot is basically saying we've found an index that we can use, right? So it being set to uninitialized means that this slot in the array, or the index of the array, is not in use. So what we can do is we'll do a k static mesh m, right? We're going to do... I just realized I'm using U32s for this, and I should be using U16s. Let me fix that. And then actually, I think that might be enough. Okay. All right, so what we'll do is we'll say m equals I, right? Oh, this needs to be U16. Right, okay. Okay, so we'll say m equals I, and then we will break, right? So we found a free slot, we want to use it. The other thing that we're going to do is we're going to immediately mark it. So we're going to say states sub m, right? We want to use that as the index, equals this, right? So in use, right? Okay, so if we get down to here, you know what? We really need to define that, right? Invalid k-static mesh will be what we use to determine whether or not the mesh is valid or not, right? Just like for textures, right? So, okay, so we have that. So now we can say if m equals invalid k-static mesh, no free slot was found, double array size, and try again. I'm going to put a fix me in here. We'll deal with this later. Make sure this doesn't overflow. I don't think that's ever going to be an issue, but put it in there anyways, just in case we hit it. So we're going to do ensure array is allocated, pass along state, and then the new count is actually going to be how do I want to do this actually? So I guess I want to do state max mesh count as let's say times 2, right? We'll just double it. Let's actually do this. Let's do U16 new count equals this. right? We'll do that. Up here, I'm going to do the same pattern. We're going to say new count rather, equals 64. New count, and then we'll do state max mesh count equals new count. And we'll take this, and we'll go down here and do the same thing. Those are the only spots that we're ever going to resize the array, right? Okay. Cool. So that's going to resize that, and then all we're going to need to do is we're going to say m equals state max mesh count, and we need to actually move this above that, right? So we need to m is now at the end of the old array, right? And then increase the max count to match the new array size. And then, actually, I think that's going to be it. Let's see. Assad, how's it going? What's happening here? What we're building is we're going through our static mesh system and we're sort of refactoring it. So we're converting this from being a system where we pass around a static mesh pointer, like to a struct that has all of the data in it, to simply using an index internally. And what we're going to do is we're going to take that index and we use it to look that up in a table, an internal set of tables, really, of the actual static mesh data. So we're internalizing all of that. So instead of referencing a static mesh throughout the system as a pointer and having to pass that around, when we don't use 90% of the data on it 90% of the time, what we're doing is we're internalizing that into a system, having that manage all of it. That way it can be all contiguous in memory. Lookups are quick. And then from there we can, get the information that we need as we need it, instead of just having it all over the place for no reason. Aside from that, we're also switching away from the resource system, which we've deprecated and we're working on removing, and handling asset loading directly within this, right? Okay, so what we also need to think about. So static mesh is referenced by name, right? And we don't actually have a way to take a name in here. We have an asset name, but we don't actually have a name. So I think we're going to use the asset name as the name and go from there. So let's actually do this first, right? So let's actually take... there's actually a step we missed, come to think about it. So the first thing we actually need to do is to see if we actually have a static mesh with that name already loaded, right? So what we actually want to do is search the names array for the asset name. Whoops. And if you recall, the K name is really just an integer, right? So this is a lightning fast lookup. And so found a match on the name, right? So we're going to do m equals sub I, and then we don't need to mark it as in use because it will already be in use, and then break. So this whole bit here only needs to be done if we didn't find anything, right? So really search for existing mesh by name, and then we actually need to do to do issue new instance, right? We need to do that. So match by name not found. Need to create load new mesh. Right? And then no slot free. Actually, there we go. Okay. So that's really the whole step there in terms of lookups, right? So we could extract this out to a function. That's probably going to be useful. This stuff is really only done once. So I don't think we really need to split this out. But this could be useful, right? We may want to search by name, right? But really, I think this is the only place this is going to be used too. So I'm going to hold off on that for now. So by the time we get down here, we should absolutely have a name, right? What I'm going to do is I'm going to do a k-assert message here. And I'm going to say m should not be equal to. I want to assert that that is not equal to invalid k static mesh, right? And the message is, despite attempts, no static mesh could be matched or loaded. Check application, actually check engine logic, system logic. Right, so we just want to assert that just to make sure. Let's see. As silly as it may seem, sometimes when I think something is difficult or that I won't be able to do it, I say to myself, Travis wouldn't have given up. You will keep up the amazing content. Thank you for the kind words. I appreciate that. Yeah, I'm stubborn to a fault sometimes. Sometimes I will. Sometimes I'll give up by saying, you know what, this system sucks and I'm refactoring it. But yeah, I have been plugging along at this for quite a while, the engine, without giving up for sure. You get past a certain point and you just keep going. Like once you get past that point, it's easier to keep going. I do have to say that. Don't really understand how changing a mesh state from uninit to uninit marks it as in use. It's because I'm a dingus. That's dingus-oriented programming right there. Should be loading. Good catch. Dingus-oriented programming. I think I have a... Yeah, there we go. W bug fix, yeah, exactly. That would have tripped me up for sure. Exclamation point DOP. All right. So we need to issue a new instance here. That's going to follow the same logic that we're going to have to do after the asset is loaded. Actually, not even after the asset is loaded. We can issue an instance right away. Okay, so the next thing, I guess, actually is going to be to set this up, right? So we have market is in use. So I guess what we're going to need to do, let me think about how I want to do this now. So when we have a new instance, we're going to have to do a couple things. The submesh data will get filled out when the asset is loaded. So that's fine. But we are going to have to set up an array for material instances, but we won't also know that until the asset's loaded. trying to think about what order of operations we should do there. So essentially the flow would be, let's say for example, we had a scene that immediately just requested 2 copies of a static mesh right away. Requested 2 instances of it, right? So we can assume that it's going to take several hundred cycles for that asset to load off of disk, right? So the time that takes to load off disk, we will already need to have issued 2 new instances, right? So we would essentially need to add in our instance data. Material instance. Oh, this needs one more layer. Now that I'm thinking about it. So we have this instance data, right, which is basically 1 per base mesh. But within that, for a base mesh, we are going to need a collection of these. So really what we need, yeah. Right, and then we need let me think. So we're going to need an array of instance data, right? One per instance of the base mesh, right? And then this will be the collection of instances for a base mesh. This is going to have to include more data than just that, by the way. So the instance data is going to need to include things like tint and stuff like that, right? Things that we want to override or things that we want to apply to a particular mesh instance. So this should be we'll say the base instance datas. So this will be instance data for the base mesh indexed by, okay, that makes more sense. Okay, so what we're going to have to do is when we set up a new one of these, we're going to have to also say states. I wonder if we should just use a D array for that. I feel like we should. I feel like this is a spot where like a D array would actually be, because otherwise we actually have to figure out, there's another thing we have to figure out too, is how do we figure out what instance is actually used and which ones have been released, right? So when we talk about an individual instance of a mesh, one per instance, this is going to be instanced or indexed by the instance ID, right? We're also going to have a state for this, indexed by instance ID, right? So we're going to need I think there's only going to be 2 states for this, but I feel like there could be more. maybe in the future. So I think what I might do, actually, even though there's only 2 states, we could make it a Boolean. Right? We'll do this. We'll say k static mesh, oops, instance states. And then we're going to say uninitialized, and then what do we want to call it? Issued? Active? I don't know. Active seems kind of... I guess issued is fine. Like I said, we could use a Boolean for this, but I'm thinking we might wind up having more than one state for that, or more than 2 states for it, rather. So, states. All right, so whenever we set up this, we need to set up these 2. I guess we could just use our resize logic. Right? We could do U16 max instance count. Right? And then we also have ensure array allocated, right? But, oh, I think I called this instance datas, I think. What did I call that? Base instance datas. And that is of what type? Right. So let's do this. Let's take, I'm going to write it right here for just a second. Right, and we're going to say ensure instance arrays allocated, right? So we want I think we can actually just pass base mesh instance data, right? I guess we could say base instance data, sure. So the new count, right? So we pass this entire structure. And then in there, we say essentially the same thing as all the way down here. Why is that over there? So essentially this, but instead of state, base instance data, right? And so this would be base instance data for all of these, right? And then same for that one. It actually, I only need 2 of these now that I think about it. So we would do, instead of names, it's going to be instances. And, oh, the type. It's going to be instance data. And then max instance count. And then this will be k static mesh instance state. Okay. So now we can take this, paste it here for a second, take this, duplicate that line, take this, go to the bottom, put that there. Now, we can do base instance datas. Max instance count. So let's see. How are we going to want to do this? So we essentially need to repeat this process that we do for meshes. We need to repeat that for instances, right? So this is a brand new one though. So let's do max instance count. I guess we'll start with like 4. We can start, actually, I think we can start with 2. Or maybe even just 1, quite honestly. So ensure instance arrays allocated. So we want to pass the address of state base instance datas sub m. Yeah, so we'll do u16 new count equals 1. Pass new count there, and then do new count there. Set up instance array data. Right. And then when we go to issue a new instance, we can do this logic. Acquired issued state. Yeah. I don't know. I'm not really... Naming is hard sometimes. Like, naming is one of the things I struggle with most in programming, to be honest. Like, the rest of it's easy, but like... International Bug-Oriented Programming, IBOP. I read that as IHOP, and now I'm hungry. That's awesome. Chat's here for the save, easy. Yeah, exactly. Damn it, now I'm hungry too. You know what's ironic about that too is I actually had breakfast for dinner. So I actually had made pancakes and like eggs and bacon. Had that for dinner. It's very funny that came up on stream. I guess acquired is fine too, right? Like, but then like, yeah, I guess acquired is a little bit better. It's like an issued state instead of issued, acquired. I guess that's fine, right? Yeah, that's fine. All right. Okay. So, where we're going to pick up next time is actually issuing the new instance and then actually loading the asset down here, which that's actually going to be the easy part. And then uploading it to the GPU, which actually isn't a lot of work. It's just mostly like scaffolding this new stuff that I have to think about a little bit more. But how do you set the WES term background to blurred? Tried to look up in the configs, KD blur setting. It's apparently, yeah, so it's a whole thing, Magets. I'll have to tell you offline because it's really involved, actually, to get this effect. And every time KDE updates, I have to redo. Yeah, it's a whole thing. On Mac OS, of course, it just works. But all right, yeah. So I just looked at the clock. I'm actually out of time for tonight. So this is where we're gonna have to leave it for tonight. Let me just do a. Let me do left off here instead. All right. So everything I've done prior to tonight is already pushed up to the repo. I'm not going to push this up yet. I'd really rather get it working first if we can do that. If we don't get it working by tomorrow's stream, which is a possibility, then I might push it when I do get it working offline. But we'll see where we wind up tomorrow. Let's see. I try and learn NeoVim 2 because of pesky, VS eats up RAM like candies. Yes, it does. Yes, it does. Essentially, whenever you have to load up that to use it, it's just like, anyway, enough of that. Left off comment is genius. Why didn't I use that? Yeah, it's something I started doing on stream, and it really works. Because then I could just search it. I've got a couple of them that I forgot to remove, but yeah, it works really well. I have a whole scene for it, yeah. It's a whole thing, like special effects to slow down the video and everything, yeah. I'm proud of that one, actually. It was a lot of work to set that up. Anyway, yeah, that's where I'm going to end the stream for tonight. So thank you guys so much for being here. I really, really appreciate you guys. I'm going to find somebody to raid. If you haven't already, I would really appreciate a follow, either on the YouTube side or the Twitch side, or if you're so inclined, both. Every little bit helps. Trying to motivate more people to get into engine development. And so the more competition we have, the better, I think. So let me see. Let me see who I can raid. Let's see if I can find something that is kind of related, maybe. Let's go with, you know what? I'm going to go with Hypnotic Games. See what he's up to. He's a good buddy of mine. Yeah, we'll see what he's getting up to on his stream. He's working on a game in Godot, so we'll see. We'll see what he's up to. But yeah, anyways, thank you guys so much for being here. Appreciate you guys. And I will be back tomorrow night at the same time, 9 p.m. Eastern, probably a little bit before that. But yeah, I will see you guys on the next one. See ya.